Hello everyone. The topic is about before topic the heading is about refrigeration and cold chain management, and the topic is about standard rating cycle and effect of operating conditions. Standard rating cycle. The standard rating cycle, it corresponds to an ideal refrigerant cycle. However, different operating conditions have different effects on the vapor compression cycle. Here there are 5 types of the effects of operating condition. First, effects of evaporation pressure, effects of condenser pressure, effects of suction vapor superheated, effects of liquid subcooling, and using liquid vapor heat exchanger. These are the 5 types of effects of operating conditions. First, we are going to discuss about effects of evaporator pressure. As you can see in the diagram on the right hand side, it shows us a curve. In this, there are the 5 processes 1, 2, 3, 4, and 5. In this decrease in evaporator pressure P1, it causes the stages 5 to 5 and 1 to shift to stages 5 and 1 respectively. As a result of the work input to the compressor, as a result of work input to the compressor, it increases by areas 0 to 1 and 1 to 2. The COP and coefficient of performance of refrigeration system thus decreases. Next, about effects of condenser pressure. In this, the refrigeration effect is reduced by an area of the temperature entropy diagram under the process 5 to 5. At the same time, the condenser work increases by an area 2 to 2 and 4 to 4, 4 to 4 inch compared to the normal cycle. Thus, coefficient of performance and refrigeration effect are reduced compared to the ideal cycle. Further, the work input has increased but is somewhat less than the increase when there is change in evaporator pressure. The effect of reduced evaporator pressure and increased condenser pressures are easily seen on pH diagram respectively. Effects of suction vapor superheat. It is usual practice to admit slightly superheated vapor before the beginning to avoid the possibility of wet compression. Wet compression is undesirable as there may be accumulation of liquid inside the cylinder, which in turn it will wash away the lubricant, resulting in several mechanical difficulties. Thus, to avoid this, 5 to 20 superheater of the refrigerant is always desirable. The vapor superheated has the following effects of the refrigeration cycle. First, it increases the refrigeration effect per unit mass of the refrigerant from H1 to H4 to H1 dash to H4. The specific volume increases from V1 to V1. This implies the reduction in mass flow rate for the same displacement volume of the compressor. The energy for compression of refrigerant vapor, it will increase due to diverging nature of the isentropic lanes. Next, we are going to see about effects of liquid subcooling. It is always desirable to subcool the refrigerant before throttling. It is seen from these figures that the refrigeration effect is increased by an area under process 5 to 5. The magnitude of subcooling is usually kept between 5 to 10. If there is too much subcooling, then the work input increases considerably. This offsets the gains from the subcooling of the refrigerant. Next, it's about using liquid vapor heat exchangers. In this, when the vapor leaving the evaporator is heated up by the condensate, the temperature of condensate decreases from T4 to T4. The heat exchanger is essentially a concentric type counterflow heat exchanger which causes the subcooling of the refrigerant before throttling. There is no change in the refrigerant effect. This is done as the heat transfer from outside is highly undesirable since it increases the energy input to the compressor and the vapor superheating at the discharge of the compressor. Thus, we have seen the 5 types of operating pressures. Thank you.